let's just introduce our lovely guests today. So we've got Jeff. Everyone knows you, Jeff, but do you want to say hi?
Sure, yeah. Hey, everybody. So Jeff DeCorpo here from eFabless.
And we've got Andy on the line as well.
Hey, a silicon dinosaur. 27 years designing chips.
Yeah. And what's really cool for us is that Andy was involved with what used to be the Cypress foundry, which is now Skywater. So it's got intimate experience with the process that a lot of us are using.
The process and the standard cells.
Yeah. Okay, so in this webinar, we're going to cover quite a bit of news. The most important one is the chipIgnite shuttle tape out happening on the 5th of June. That's for 100 QFN parts on Sky 130. And also the AI competition, which is closing Friday, June the 2nd. The next chipIgnite shuttle is 2309C. That's on the 11th of September for 300 parts. If you joined us for the last webinar, the analog layout one, where I had Tim and Thomas demoing K-layout and Magic, we took the full-length version of Tim's op-amp layout, and that's now available on YouTube. So if you want to check that out later, you can follow that link. We're going to cover a little bit on the chipIgnite 2206 silicon validation. We're going to look at early silicon validation for GF180. We're going to look at some user project test results for the chipIgnite 2206, and we're going to spend probably most of the time on the AI competition. Let's see how we're doing. Sorry, we're unable to see the posted link. Okay, yeah, no, I had this problem before. I posted my posting my stuff only to panelists. There we go, me to everyone. So you should all get that now. So I'm going to hand over to Jeff now to give us an update on chipIgnite shuttle status.
Okay, great, thanks. So we want to cover a couple of updates both on the chipIgnite as well as the OpenMPW shuttle status. I know we've been working through a number of issues here over the last, since summer last year, regarding some of the addressing some of the issues with around design. I think Andy's kind of covered some of that in other videos. We've also gotten a lot of feedback, and I know there's a lot of concern around just our kind of schedule and kind of the time it's taking to get silicon back on these shuttles. And I want to let everyone know this is a top concern that we're working on, and we're working to address. But hopefully we're starting to kind of turn the corner on that as well. And we're starting to see silicon come back, and things start to pick up and move and start to begin to flow through our process and through the fabrication process with both Skywater and then as well as the shuttles that the shuttle we're doing with Global Foundries. So a little bit of update on chipIgnite first of all. So the first silicon that we had come back with an updated Caravel design is been returned back from the foundry. We had run that project. These projects are all submitted last year around April and June of last year. And we ran that fabrication at a very high priority status with the foundry, right? To get that back, to get that silicon back as soon as possible. We have that back and
Lost Jeff temporarily there.
Yeah, I think we did. I'll continue, and hopefully it comes back. So we got that silicon back on May 1st, and we were able to get wafers processed for silicon testing by the 4th to be able to get some very rapid turn on what was going on for packaging. We lost you, Jeff. We got that silicon back, which is around about the May 1st line.
Am I back?
Yes.
Andy took over for
Okay,
you.
I'm back.
Yeah. Yep.
All right. Okay. Am I here? Can you hear me now?
Yes.
All right. Great. Sorry. So I was saying that we have So we got an initial wafer back and processed to get some early silicon validation testing done. That was on a very small set of dies that we did a very quick turn packaging process to get them back quickly. The rest of the wafer is going through the full packaging cycle or processing cycle, and we're expecting to get kind of the first split of that packaging job back here at the end of the month on May 29th. And we're going to be getting those on breakout boards assembled on PCBAs and out to users. Our target ship date is on June 5th. So those are going to be on the way. The rest of them are coming out, and we're going to continue to package the remaining parts, which is another 90 per project, and we'll be sending those out in late June when they're completed. All right, so that's kind of status on 2204, 2206, 2211. Which was taped out end of last year, is in fabrication. We're currently running at 19% complete on that. We're continuing to follow and work with the foundry to make sure that stays is on track and accelerate and escalate and accelerate where needed to keep the schedule on that project or that shuttle. Okay, I think with that, we'll just move on to the next slide. So a little bit on the Open MPW shuttle updates. So these are the Google shuttles that are sponsored by Google. The first one, MPW2, has already been shipped, which hopefully most people have seen. So I think all users, with maybe one exception, have their projects at this stage. And have been able to, and many of those have had some experience with testing those. We have MPW3 about to ship. We had an issue during board assembly, the final board assembly of those projects on breakout boards, where we had a number of the parts were reversed when the vendor went to assemble them. So they were kind of 180 degrees flipped around the wrong way. We caught that during final kind of testing before shipment, and we've gone back to reassemble, basically scrap those boards and reassemble a new set with new parts. And we have those returned yesterday, and they're currently under test. So we're expecting to start shipping that early next week, as we just verify that everything's kind of meeting and passing our final test procedure. MPW4 silicon is fabrication completed on that, and we are in process of getting that packaged, and then we'll be doing the similar steps to assemble those on breakout boards and get those out to users. Excuse me, I got a window pop up here. And then MPW5 is also in fabrication. So those are the shuttles, MPW2, 3, 4, and 5, that have the original Caravel with where we identified some hold violations that are getting in the way of GPIO configuration. All those projects need, we have a solution that uses a Nucleo test setup and board to characterize the IO chain to configure those and provides a workaround for configuring the IO for those specific projects. Beginning with MPW6, including and then going on to 7 and 8, all those shuttles basically have the new Caravel design. That's the one that I just referred to earlier in terms of we got silicon back and tested. Those all should be correct, should work as spec'd, and they don't have any issues related to the GPIO configuration that we had talked about previously. So those are all in fabrication today. They're kind of like, you can see they're sitting at 60, 40, and 7% completion respectively. If you haven't seen it already, there is a page that we're maintaining on a eFabless website, which is linked below, where you can continue to track progression of those through fabrication. And the last one on the list here is GFMPW 0. That's the GF180 shuttle that was taped out end of last year. We have that back as well. We are also doing a very similar process in terms of early silicon validation testing. Andy's going to talk a little about those results. But we are currently in the midst of running the rest of the shuttle for the rest of the projects through packaging, and then we'll be getting those on board, assembled on breakout boards for shipment out to users. Okay, I think
we lost him again. Okay, so this is the status of the Caravel. Oh, we've lost you again, Jeff.
I think you lost me. Sorry about that. I'm going to try switching over to another. Why don't you go proceed? If I covered most of the items, why don't you proceed to the next
Perfect.
slide?
Let's hit this one then.
So you want to do this one then,
on this foil, so this represents the chipIgnite 2204 and 2206 silicon testing to date. So this is a set of tests that we were basically struggling very hard to try to run on MPW2. And we had to do a lot of IO configuration work to be able to get around the whole problems to run many of these tests, and some of them could not run. But this is the Caravel we got for 2204 and 2206 silicon. We've now tested it from 1.98 down to 1.7 volts, and we're seeing the full suite of bring up tests we're expecting to do on this silicon passing. So the good news is Caravel is now meeting its specs, and it's meeting its specs well enough across a range of voltages, all at room temperature, but across a range of voltages that we are confident that from a prototyping perspective, people should have a good experience. And that's the kind of major news we're trying to get across on this page. And if you're interested in more information on the bring up, there's a little video there. If you want more information on the details of what the issues were, there's a little video there. And they'll give you a little bit of background on what went wrong and what we've done about it. Okay. Next page, Matt. There you go. This is you.
Yeah, actually, I'm going to just go back one page and say, yes. I've been, I'll explain a bit more later, but yes, all the big amount of green here makes life a lot easier. And yes. I really recommend watching this video to find out more about that, which is like a 45-minute interview that we did, Andy. And I just think that, you know, one of the things that we're changing here with the world of open source silicon is like sharing information. Yep. And it's so rare to hear the level of information that Andy shared in that video. So I would really recommend checking out. For the person asking for the links in the chat, check the slides, which is here. And then you can just click on any of the links you're interested in. I'll just post that there again. All right. So yeah, so showcase. So this was actually maybe Jeff, you know a bit more about this, didn't you?
Yeah, hopefully I switched networks here. Hopefully it works a little better on this one. Sorry. So yeah, we're gonna talk. So like as I mentioned, we got on the first the chipIgnite 2206. We got some early silicon package for initial testing. That was a lot of that was focused around validating Caravel, which Andy just covered. But we also have a few user projects on that as well. This is one of those on the left, which is a Delta Sigma ADC. And so just began kind of showing successful test results for that project. And I think this is a student over at Stanford. So they're going to be, I think they may be publishing these results here, but their project is public. If you're interested in checking it out, we can provide a pointer to it. The pictures on the right are just just giving you some little flavor of kind of some of the new hardware. If you're familiar with kind of MPW2, one of the challenges we ran into is we were using a flexi pin socket. That's been since updated now with a new solution that uses an M.2 micromod connector, right? That is providing a much easier kind of zero insertion force type connector that you can and then connect your part sitting on a breakout board into, and makes it much easier to use. The little picture above is one of our test setups that runs kind of full automated test suite that Andy was referring to. So that's also an area that's been under a lot of development and evolution here through the process. Okay, Matt, when we move on to your next slide.
Yeah, so I'll talk about this one. So one of the designs that I had on one of the hot lot that Jeff mentioned earlier for testing all the Caravel fixes was this project that I did in collaboration with Teo. If you're a subscriber to my YouTube channel, you might remember it. And when you're doing writing Verilog and you do something like the output equals A plus B, then Yosis, which is a synthesis tool, uses a standard behavioral model for doing that addition. But there's a big range of types of adders that you can do, different topologies, and you get different power, performance, area trade-offs depending on what you're using. And one thing that Teo did was wrote a plugin for Yosis that lets you choose which type of adder is going to get synthesized. So if you want something that's super performant for an ALU, but it's going to be bigger and use more power, then you can use that one. And if you want something that's really slow because you're going for low power or area, then you can choose something else. So what we did was we built a ring oscillator, and then we can take the output of the ring and put it into any one of the bits in an adder, and control the other inputs, and then take any one of the output bits and then put that back into the ring. And then down here we have like a simple state machine and some counters and some flags and stuff like this. And we've got 5 of them, the basic Yosis one, and then 4 of these other topologies that Teo implemented as in the plugin. And when I got the board from Jeff, I was able to get 10 out of the 11 projects like working with some kind of output within about 2 or 3 hours, which is just incredible, because MPW 2 took maybe 2 or 3 weeks to get 20 or 30% coverage because of the IO issues. So it was so nice to be able to just set up well, basically I just ran the firmware that I had for the simulation and testing, and the outputs on the scope matched what I was expecting on GTK Wave. It was almost like it was working, which in fact it was. So this picture up here on the top right shows the ring oscillator turning on, and we've got the 4th bit of the counter, which is the purple line here, oscillating. The serial portal works, so I was able to write a serial instrumented test bench to run hundreds of loops and then get the averages. And then I was able to put all that into a spreadsheet. And we started off just by characterizing how fast the clock is, exactly what the clock frequency is, the clock period, and then calculating out what the inverter delay period is for each of the different ring oscillators in each of these adders. And then the next step will be tracing the lines through the adder to see which is like the fastest and slowest path using STA. And then we can validate that against actual real world measurements. So really cool to be doing this kind of experiment and pushing out the realms of the tools that we have available to us with open source synthesis. And that was all just extremely easy to get up and working. So it's really great to be doing that. And the other slide I've got here was some results from the MPW2 bring up, which, as I mentioned, was quite a lot harder. You can check out the slide deck here. It's only actually got 4 slides in it at the moment, and included here are these 3. And I think they're all really good, but this the FPGA one was especially cool, I thought, which was an open source FPGA fabric that was taped out. And if I just click on here as well, we can see a video that was put together of the FPGA with a little program running and creating video. So a really great result there from Myrtle and Dirk's team on the fabulous FPGA FPGA fabric. So next slide is this one for you, Jeff.
Actually, it's Andy.
Yeah, okay. So reflecting on the conversation we just had for Skywater, so we have literally, we've had a hell of a 2 weeks or 3 weeks here, and we got the Skywater silicon back on the, I think it was the 2nd of May, 1st of May or 2nd of May. We got the GFMPW silicon back on the 5th of May. And so it took us a couple of days to get caught up with the Skywater testing and get the GFMPW 0 up on the test bench. We had dev boards and packages by the 8th of May. we had identified that there were some problems with our bring up board by the 9th of May. I will describe the current instance of the bring up board as being blue wired to death. So we had put in some level shifters and buffers associated with 5-volt operation of the GFMPW 0 shuttle. And one of the buffers we had chosen in the dev board implementation was not a good choice in retrospect. And so we did a little bit of blue wire. And the positive part is with the blue wires, we were able to get everything on the board to work. And the testing status is on the right-hand side. So we have about 30 tests there. Of the 30 tests, there are 4 that are not showing green. The first one, SPI master, is manual. It's also manual in the Sky 130 test bench. And that's because the Digilant-based mini tester we built, shown in the picture that Jeff showed earlier, is not able to do the SPI master test automatically right now. The next 2 are literally in the process of being automated. And the last one is in debug. There are 4 pins on the HK-SPI interface on the GFMPW silicon that in our test environment are not toggling the way we expected to for pull low. And that is likely, very likely, a board test setup issue, but we haven't had a chance to finish the debug on that yet. And that's probably going to happen in the next 24 or 48 hours, but not completed. And that's the only thing we've got in debug. Everything else is passing. So we expect people using GFMPW 0 to have a very pleasant bring up experience, much like the people who just used the chipIgnite. And I expect to get some parts out to Matt in the very near future and be able to have him start to do project bring up to prove that that goes well. And then get the general parts out to the consumers at large in the first week of June. We'll get new boards with modifications, and second week of June we'll be delivering parts. So I think that gives you guys a rough idea of where we are, about 3 weeks away from parts going out to customers.
Okay, I'll do this one. So for people wanting to take part, actually there's let me do this. There's a polls and quizzes. Let me launch this one. There we go.
I didn't do the yay on the last page, and I probably should have, because we just went the whole way through the process to first silicon working, Matt, in one iteration instead of in 8 iterations. We probably should have celebrated that a little bit.
3, 2, 1.
Yay! Exactly.
Yeah, so these are the getting started resources if you're planning on taking part in chipIgnite, and this is also going to be the same thing for the AI competition. You want to be using the MPW9C tag on the Caravel user project. We've got CI that's showing everything. If you follow the instructions, you should be able to harden and get valid local tests running and the pre-check running. We've got the quick start guide here, the user community on Slack. Probably everyone here is already a member of that, but if you're not, then that's good to join that. And then there's a documentation, OpenLane and Caravel. And the MPW6 walkthrough video that I did a while ago is still mostly matches. The main thing you need to change is at the beginning when I say check out the repo MPW6, you instead need to be checking out MPW9. So this will hopefully get you started. Otherwise, if you do have any problems, then the best place is to contact us on the Slack. Okay, a couple of gotchas to be aware of. Analog is not currently passing on the tape-out job at the moment. Caravan is being updated at the moment. So if you're doing analog, that's the reason you're using Caravan, then just let us know in the shuttle channel, and we'll let you know when Caravan is ready. We'll also be running any tape-outs required for analog jobs, so that's not something that you need to run in the eFabless platform. And the other thing is, we're recommending to use DFF RAM for memory, if possible, on this shuttle, because we know that the timing model of Open RAM has some issues. Any other gotchas?
I was going to say, to be clear, it's not clear that the Open RAM itself has any issues, but at the boundary of the Open RAM, we've had integration issues on a couple of different projects. So that the timing model for the Open RAM appears to have timing issues at the boundary, and we've seen that in a few projects. So that's the warning there. If you're using it, you're doing it at risk.
Yeah. Nick, current Caravel design that we're using and just validated testing uses DFF RAM.
For Sky 130.
Sky 130.
Yep.
Right.
Yeah. Having said that, my latest chips have a multi-master Wishbone bus with a 1 kilobyte Open RAM macro on it, and the tests work perfectly.
Yeah.
So who knows?
So it's iffy based on an individual instance of integration.
That's anecdotal. So
Yep.
trust Andy.
Well, yeah, I mean,
you can use it. You're just taking some risk.
You can use it. We definitely see it work. We've done, we've had our own testing on MPW2 silicon initially back last, and we've seen tests, significant number of tests pass, right? But we'd also seen some failures. So the issue is, just for if you can use DFF RAM, then that it's probably a better, safer bet, right?
And to be clear, there is work planned to happen on this over the course of the next couple of months. I'm pretty sure Matt Goodhouse is dedicating some time to it over the summer. So it's something we expect to get resolved. It's just not yet done.
Correct. The other one on the analog is we are obviously, so if you're submitting an analog project and your tape out doesn't pass, obviously for the reason that Matt just mentioned, don't worry about it. We'll see it. We'll make sure it does get rerun when Caravel is updated. You can definitely reach out to us with any questions you have.
Yeah, and talking of questions, it's good to see the results here. So nice mix of people.
We're not able to see your window, Matt.
Oh, that's interesting. Stop sharing. Okay, well, so we've got 30% student, 30% teacher, 30% working in industry. Majority of people in European time zone. I guess that's not surprising. Mm-hmm. Most people haven't taped out, but 6 people have taped out once and 5 people have taped out more than one time. 40% want to do a digital tape out, 40% want to do an analog or mixed signal tape out. 50% of people are saying they're interested in using chipIgnite for a project, and 80% of people want to be added to the eFabless mailing list. So thanks very much for your participation in that poll. Now that I've clicked end poll, it's got the button saying share results. So didn't need to read all of that out.
Now we can see it, yeah.
Now you can see it. Oh, right. So can you see it on my screen, or it's popped up?
We can, it's showing up now.
Okay, right. There you go. So, yeah. All right, let's move on then. Okay, so I don't want to read out all of this, and you've all got the slide, so you can go through. But we asked Nathan and Marmik, who've been doing a lot of good work on the chipIgnite outreach, what their most frequently asked questions have been, and put them all together here for you. So these are the most frequently asked questions about chipIgnite. If you do have any other questions, then probably the chipIgnite channel in the open source Silicon Slack is the place to go and ask them. Do either of you want to mention anything on these slides?
I think there are some questions on maybe worth touching on ReRAM. So for people who have an interest in ReRAM, so there's some questions around, what is the P, am I using Sky 130A versus B? And I think the answer is for almost everybody who's not doing a ReRAM, is not implementing ReRAM in their design, they should be using the Sky 130A PDK, right? And we in cases where we have a ReRAM project, you can submit a ReRAM project on chipIgnite or on in the future for any open MPW shuttles on Sky 130, but we basically run a split lot. So we will run some wafers with ReRAM processing to support those projects that did implement ReRAM. They will get a different wafer they'll get their dies will have ReRAM processing on it. The people who did not implement ReRAM will not have any ReRAM layers in their die. So basically the answer is we will support ReRAM and we will do the processing as needed if there are projects on a particular shuttle. For ReRAM, we'll split the lot and we'll run wafers separately for those ReRAM projects. Does that make that reasonably clear, Matt, or any other questions?
Yeah, I think so. Yeah, and maybe it's just worth saying that when you do your setup, you choose between Sky 130A, which is without ReRAM, or Sky 130B, which is with, and because the layer heights are slightly different, that also changes parasitics and timing results. So that's why you've got to choose one or the other and then stick with it.
Yep. And I think it's default to A, but we'll confirm that.
Andrea just asked, what's the lead time difference in the two lots? Interestingly, Andrea, at least in the lots that we've split so far, they've recombined them for the later layers. So the lots came out of fab at the same time. Both lots got delayed by the ReRAM processing. That might be something we try to convince them to change in the future. But the approximate impact was on the normal cycle time was about 2 weeks. On the expedited cycle time, it would be something just over a week.
We've actually got we've got a few open questions. Aaron is saying ReRAMs are still a big issue. ReRAM simulations, yes. Does anyone know about that?
No.
Aaron, maybe you can let us know in the chat what the exact issues are that you're having with the simulation. And then we've also got Lewis saying, do you have any info to share about the Open RAM issues? So maybe you could also...
I can give a brief one on that. I don't know the issue for the ReRAM simulation, so that would be good to go through. For the Open RAM issue, the issue is the timing model. So when you're integrating through synthesis a memory in a block of logic, the synthesis tool uses the model that you provided, .lib, to be able to understand the interface timing between the logic regions and the memory hard macro that you're just instantiated. If the memory model is a little bit aggressive, as in it underestimates delays, you can end up with a setup time problem. So you can end up needing to run at lower frequency because you can't hit the timing target. If the timing model is a little bit conservative, as in it overestimates delays, especially on data relative to clock or data relative to an enable signal, you can end up in a position where you have a hold time problem. And the issue that we encountered with the Open RAM in first instantiations was a hold time problem at the block boundary. And that was the example that we've seen on silicon. And that's only because of the fact that the timing model itself wasn't done well. It's a very old model. We're kind of understand what the origin of it was, and it needs an improvement. Matt knows how to do the work, has a guy working on doing the simulations to be able to get it to the point where he can build a better timing model, but that timing model is not done yet. And so there's some risk when you instantiate the memory that you might or might not end up with that hold time problem. And the downside is if you end up with the problem, you might end up with a chunk of your data space that doesn't work. So that's the downside. There's a possibility, and it's a real possibility because we've seen multiple instances of it, that you instantiate the memory, and just because of the amount of margin you have in your design, it works fine. And so we may be able to come up with a margining methodology that would work in general for Open RAM, but we don't know what it is yet because we don't know how far out the timing model is because we don't have the real timing results yet. And so we don't have a concrete way to say this is how much you'd have to margin your design to be sure it would work. And that's the reason we haven't got a response better than we recommend using the DFF RAM for now. So Luis, I hope that answers your question. For the ReRAM question, I actually don't know the issue.
Yeah, I asked Lewis to provide a bit more information. And there's someone in the chat is saying, how about flash devices?
There's no current embedded non-volatile device qualified in our technology. Now, that doesn't mean that there isn't a cell that's capable of being used to make one. There's the basic element of an MRAM cell that is and a Sonos cell that are each available in Sky 130. The Sonos bit cell would require a significant amount of work to be able to develop a memory from. And that work would have to be done by parties, in the open source domain. There's no off-the-shelf NV memory available in this technology today. There is a company, Weebit Nano, if my memory serves me correctly, that has made a qualified ReRAM-based non-volatile memory in Sky 130 or a derivative of Sky 130. I have not been approached by anybody to try to instantiate that in a chipIgnite. We would not be able to put that IP in an open MPW run because that is a proprietary IP and we can't put it on an open MPW wafer. Okay, so hopefully that answers where we are.
Yeah, thanks, Andy. Okay, so I think what I want to do is move on to the AI generated open source silicon challenge, because we've got about 25 minutes. So I want to make sure we get a good chunk of time devoted to this. So maybe Andy, if you don't mind, you're the kind of the main power behind this competition, aren't you?
Give it an intro. Okay, starting point is everybody recognizes the impact that generative everything is having on the industry as a whole, and having on all industries, I would say. And we wanted to try to understand the state of the art in the silicon space, A, and B, we wanted to see if it was, is it yet mature enough to be able to do some interesting designs on the shuttle. So we set a very ambitious goal about 4 weeks ago that in 1 week we would launch a shuttle competition and give it a 3-week deadline and see could anybody produce anything meaningful in 3 weeks using AI, which would have evidenced that, A, it would be very unlikely that they could have done it without AI, and B, that they knew how to get through our flow relatively quickly. So that's the origin from our perspective. The shuttle deadline is June 2nd. It's coming up very fast. There's a very broad spectrum of people who have talked to us about trying to enter. Everybody from a person who's opening the ChatGPT prompt for the first time at one end of the spectrum through to a group of researchers at NYU who've been doing research in this space directly for nearly 4 years. And so there's a very broad spectrum of user base. We're currently proposing to have multiple shuttle slots available to win. And there's no specified maximum number on that. We've been approached by a couple of people in the industry who've talked about sponsoring extra slots if we get some very good designs. So we have a minimum of one, a maximum of some number determined by how cool the designs that get submitted are. Okay, let's pop to the next page.
And just to clarify, a statement you made, you said shuttle deadline. It's really the contest submission deadline is the 2nd.
The shuttle deadline is the 5th. I apologize. Very, very important. The reason for the difference between those two deadlines is that between the 2nd and the 5th, over the weekend that we're not working again, we're supposed to figure out how to judge all the submissions, make sure that they have all the appropriate documentation, meet the quality bar and our open source. And then we're supposed to go through that with the judges on Monday to be able to meet the shuttle submission deadline of the 5th. So the origin of the Friday the 4th deadline is unfortunately real, and it's not going to get extended to the 5th because we have learned from painful experience that moving the shuttle deadlines is a bad idea. Okay, before I jump into a brief prompt discussion, are there any questions about specifically the kinds of the state of people's submissions or things that they would like to have answered in a conversation briefly? Because I think that if I target this at questions from the community, that will probably work best. To Nicholas, the group at NYU is Hammond Pierce is the name of the assistant professor. And the paper is actually up on the Generative AI Silicon Challenge website. It is, I can actually copy and paste this paper directly into chat. It's on the next page also, but I will copy and paste it into chat right now so you get the answer. That's their latest paper. Any questions before I jump in? Design ideas from anonymous attendee. I'll tell you what I've learned to anonymous attendee. I started off with a relatively simple design, an up-down synchronous counter. And one of the things that I've learned from trying that design is it takes a very small number of prompts, less than 10, to get reasonably good RTL for that design problem. So, a synchronous up-down counter with a registered start value, a compare value, etc., you can get that in less than 10. So if you want to try to, you're unable to see the posted link. That's interesting. You're able to open it, right, Matt?
Yeah, it's with Zoom, it's a bit, if you don't make sure the 2 says to everyone, you're more likely to just send it to one person, but I forwarded it to everyone, so it's done.
Appreciate that. Thank you very much. Okay. So the PDF on the right-hand side is downloadable. That paper's in public. It explains clearly the methodology that they used for development. To Anonymous, I would suggest something much more complicated than a synchronous up-down counter. Minimum complexity, to try to pick an example, something like a useful peripheral for a microcontroller at minimum complexity. I think the highest complexity submissions that I'm aware of people trying to do, just to try to give you the all the way at the top discussions. One group is trying to submit a full microcontroller in the user project area, and another group is trying to submit a reduced instruction set microcontroller with very small memory implementations in logic. So we've got a group that's actually trying to do a full-on implementation of a microcontroller with all its major blocks in the user project area. And so that's the upper end of the spectrum. At the lower end of the spectrum, timer counter PWM block or synchronous peripheral for a microcontroller, so that it's interesting. It's a complex enough problem to test out the tools, and you'll learn the flow, the open lane flow. Okay. In terms of things that are super useful in getting your prompts right, first of all, I would suggest that if you have not seen that paper before on the generative AI channel, that you join the generative AI Silicon Challenge channel on Slack. That's in the open source Silicon Dev Slack channel, and that you take the time to read through a couple of the links that are on there. I think it'll be very helpful. You read this paper from the NYU guys. I don't think that there is a better documented example of how to do Verilog RTL generation with AI available online right now than the paper that they just published. And that paper came out, 24 hours ago. So it's really worth taking a look at it.
Very accessible, easy to read.
Yeah, very, very understandable, easy to read, and very easy to understand how to be useful using that tool. The other thing I would say is it clearly recommends a best AI currently based on the time that the paper was written. The paper was unfortunately written before Palm 2 was made available from Google. So I don't know how Palm 2 would have influenced the results. Getting started with Palm 2 is more complicated by a large stretch than getting started with ChatGPT. So, to set up an interaction to Palm 2, you need to set up a web server in the cloud with an API to Palm 2, and then you interact with Palm 2 from your web server. In the case of ChatGPT, you open your browser and you enter text at a prompt. And so that lowers the barrier to entry considerably for the ChatGPT approach. Okay, I'll start with prompts. I have been talking with many people about how to use GPT effectively. And these are the basic things that you need to be effective. You need a role, a task, and then the detailed definition. And if you don't give ChatGPT a role, it understands that it is generically ChatGPT, and it doesn't try to have a persona associated with the response. If you give it a persona, you get a response based on that persona. So if you tell ChatGPT, you are an RTL coding expert, and I would like you to develop an RTL block for XYZ, you're likely to get a different response than if you tell ChatGPT, could you give me an RTL block for X? Okay, so that's point one. Bear in mind that the algorithm for all large language models is based on satisfying the next word or next sequence of word requirements with the maximum possible reward. And so it is adding words based on a prior context and solving problems based on a prior context. Context is useful. Second point is to give it a task. I would like to code a synchronous up-down counter or a timer counter PWM block peripheral for a microcontroller that is targeted for synthesis into silicon. So you give it a definition of the task, and you'd like to point out in this case that it's for silicon rather than for an FPGA target, because you want it to implement the resets differently. The next one is to define all of the inputs and outputs and interfaces to your block. So you want to make sure that whatever it is you're trying to code in your piece of RTL, and again, assuming in the conversation here that we're going to do this at a block level, you want to make sure your inputs and outputs are completely specified. I have tried not specifying the inputs and outputs and giving a very broad definition like wishbone block interface or APB bus interface. And those are well enough documented in open source training cases that ChatGPT understands those and in fact codes them very well. But when I've tried to define a small set of signals on a synchronous block, I've had to define the signals explicitly. You want to define the block operation explicitly. So anything other than, you know, the normal concept of up-down counter, if you have the start compare values, if you have an ending value, if you have wraparound functionality, if you want to be able to provide sawtooth functions or other unusual functions in your timer counter block, you need to define what those operations are going to be. You need to define reset states. And last but not least, you need any complex state machines. ChatGPT, latest instantiation, the ChatGPT 4, is actually pretty good at coding test benches for testing its own designs. And so you may discover that writing a piece of code or a piece of prompt as simple as, can you develop a test bench that would test the block we just defined based on its definition, will work to be able to generate a first pass. The context depth of ChatGPT is about, if my memory serves me correctly, something like 30,000 characters, 30,000 units. I don't know if that translates exactly to characters. And that means that if you expect ChatGPT to follow in a conversation a piece of context that was more than, let's say, 20 or 30 chats ago, some of that context will have wrapped off. You need to be sure when you point to something with a question, you're pointing to things that are relatively recent in the thread of interactions you've had. Okay, I've got 2 questions online. May I know from where one needs to start for a new design Caravel project for the AI design challenge? The simplest example to start doing the RTL is to go to ChatGPT and start defining your code. The actual prompt for ChatGPT is, I will literally paste it into the chat, and I need to get this to all. I can't do this to all, I'll send it to you, man. That is the prompt for ChatGPT for the version of ChatGPT that I'm currently using. And that's the simplest place to know where to go to start something. There are many other AI tools. That is the one that I have found the most progress with the lowest barrier to entry. So not that I know that it's the best, but I do know it's definitely got the lowest barrier to entry to getting started and doing something very interesting.
And in terms of like creating a project for, putting that RTL and creating a project for chipIgnite, I posted a link for the project on GitHub that you would use as a template to create your own repo project. But that we can cover that as well here coming up.
Yep.
A little more detail on that.
Perfect. So if I go back to the prompts discussion for a second, the most common defect we found is the continuation problem in ChatGPT. Now, in ChatGPT Plus, you're less likely to encounter this. It has a significantly longer answer context. But in ChatGPT, it has a short answer context. And that answer context, unfortunately, means that often it will code until it runs out of the ability to code in the window. And then we need to ask it to continue. The simplest way to do that is to literally text in the prompt, continue from, and give it a little code snippet. And again, in the the generative AI Slack channel, in the Word document or Google document that we posted on there, I should say, the generative AI Silicon introduction Google Doc that was posted early on the channel the first day. I've got some prompts in there that are examples of how I've resolved defects in the RTL that I've been generating. The other one is to point out and resolve an observed bug. And there are 2 kinds of bugs that I've observed in the examples that I've been generating myself. One kind of bug is a missing feature or a missing component in the RTL, and the other kind of bug is an incorrect or incomplete component in the RTL. And so I'll describe how I've dealt with each of those. And again, they're documented in the Slack channel Google document. The first one is to say the code for X, whatever code snippet is, appears incorrect or has a bug. I wanted to do Y instead. Could you resolve that? At which point you'll get a new version of the code. The other is the code is missing, or could you add? And those words, the keywords missing or add, work very well to try to define pieces of text you want to resolve. And it is literally a conversational AI. If you operate with it as you would a junior engineer sitting at a desk in front of you coding for the first time, you're probably going to do pretty well in terms of defining what it is you want from an output perspective. Question to the community. Who has already done a chipIgnite of the people that are on the channel? I think we got that earlier on. You got about 30% taped out already, Matt?
Let me have a look. I think it was
to Hugo, I'm going to give you a code example in a few seconds. So hang on just a second. I'll actually run it live in the last minute or two of the call, just so we get something and we're able to make progress.
11 people, so 15%.
Got it. Okay, so the biggest barrier by far then for the community on the call is that they haven't run OpenLane, not that they haven't run AI. Okay, so let me take a second, Matt, if I can, to share my screen with the ChatGPT window, and hopefully give these guys an example of literally getting started with a prompt set and generating something that's useful. Okay. Can everybody see a ChatGPT window?
Yep.
Fantastic. So on the generative AI channel, up near the top on the Slack channel, there is a posted Google document, generative AI ChatGPT prompt example. And this is literally the prompt example that I used for the video we generated. I've got 2 updates since then to try to explain to you how to resolve different kinds of issues that I've seen in the code. But I'll start with the basic block definition. So I want a block that's an up-down counter with an APB bus interface, synchronous. It should have a sleep B mode pin. This will sound very familiar to the people who listen to the video. It should be disabled when sleep B is low. The counter should support a 32-bit count value. The counter should generate a pin interrupt when count equals compare. And the counter should have a start value loadable from a buffer. We can check that when we get the code. And the counter should have a compare value loadable from a buffer. And the direction of count up down should be set by a 2-bit direction field in the operation register. The versions of the code I get usually miss that functionality. Okay, and we're going to take this exact set of prompts. Could you generate Verilog? And I'm going to paste that exact set of prompts as is. It's the same text as here. Going to paste that set of prompts into ChatGPT. Could you generate? And hit enter. And this is the shockingly capable piece of generative AI. Daryl Miles, I can see Hugging Face models in Andy Tabs. What other models have been tried? I have tried about 10 models at some level. I am having by far the best success in terms of lowest barrier to entry using ChatGPT 4. And so the reason that I'm using it on a daily basis is because I'm having the best success. If you go through the generative AI Slack channel, you will see that there are 2 papers in there that benchmark different models and talk about what success has been had with the models. As of the work done by NYU, ChatGPT 4 was the best model. Again, PaLM 4 came out after that work was completed and hasn't been evaluated versus those models, okay? So it generated code. It's got an APB bus interface. It has a direction field, although the register is not called operation. It's got a 2-bit direction field. It's got a count. It's got a start value, a compare value. It has the ability to load them. It has a sleep B register. It has an interrupt register. Basic functionality all appears to be there. It has a reset value for the load compare and load start value. That does not look correct. Oh, compare value defaults to FFFF. That's good. It is correct. It's setting the load bits back to 0, which was the request in the code. It's got 2 cases defined, 1 count up and 1 count down. So I think there's a pretty high probability that this code does something useful. And do we have all of the code?
One thing that I found very interesting from reading the paper was that they also asked ChatGPT to write the test benches.
Yep. So let me do something different. So I don't know if you guys know, but Caravel has a wishbone bus interface. So let's modify this for a wishbone interface. Could you update?
And while that's going, there's a few open questions, Andy. One that's been open for a while is from David Lansendorfer. Can you see that one?
I can at the top. Give me a second. ChatGPT and Baby AGI, creating Verilog accelerator modules for matrix convolution, other matrix operations, and RAM for loading various layers. Should you? That would be a fantastic thing. And I think there are multiple people who would be interested, David, in that design, both in what you're doing and in how you did it. So that I think there's multiple people interested in the direction you're going in there, David. Many people. And to Andrea, you can fix bugs yourself, or you can fix bugs with the AI. I strongly recommend you fix bugs with the AI. The reason is, if you're coding one small block and fixing the bugs yourself, we're looking for a documented history of how you got to the result. And so that'll take quite a lot more work for us to be able to go through and be able to establish that it's reproducible. If you're doing it with the AI, it's much easier just to review the prompts. Okay, so did we get a wishbone bus interface? We've got address and we've got data. We've got read data. Yes, with a write enable, strobe, cycle, sleep B, reset, and clock. Yes, we got a wishbone bus interface. Does it do all the same things? The reset values are the same. It doesn't look like it introduced any bugs. And we've still got the same 2 cases and they still do the same thing. I'd have to check the logic in the if conditions for the buses. But other than that, it looks like it's broadly correct. So it looks like it was able to deal with the up count, the down count, the translation from APB to wishbone very easily based on the prompts we gave it at the start. So let's ask it the verification question. Sorry for the typing. Would you go about and this is me inventing a prompt live, so I've never tried this before, and I've not been working on the verification problem at all. And I'm going to fix my typos because I think that doesn't help. To answer Hugo's question, when you get a set of HDL code that has the Wishbone bus interface and the appropriate other interfaces, there is a very, very useful thing called a Caravel user project wrapper. And I happen to just have the RTL for the Caravel user project wrapper open in a Google Doc. And what I have done to try to integrate my block into the Caravel user project wrapper, which is available in GitHub as part of the Caravel project. So when you want to go integrate, I have pasted that code for the user project wrapper at the prompt and asked it to integrate the block with the user project wrapper. And if you give me just a second, we'll get there. So I asked it to write a test bench for the up-down counter. It has the same set of signals, has the bus interface. It initializes a set of signals, and then it tests a lot of cases.
Andy, I was just referring to the paper. Their prompt that they used was, can you create a Verilog test bench for this design? It should be self-checking and made to work with iVerilog for simulation and validation.
Okay, so let me write that out exactly. Can you create?
Copy and paste it from the paper, I think.
I don't have the paper open.
Let me paste it to you in the chat.
There you go.
Absolutely. The Zoom chat is so overwhelming. Deleted all the spaces. Oh well. Maybe
okay. Okay. So, but there is a very good prompt in the paper, was your point, which is better than the one that I've used. Yeah. So let me help Hugo with the example of how to integrate. So could you integrate the up-down counter block RTL in the following and then I literally just select the user project RTL. Go back to my ChatGPT window and paste the RTL code and hit enter. So Hugo, hopefully that gives you an idea how to solve that problem.
Andy, while it's doing that, could you answer Srihari's question about evaluations for newer models?
There are multiple people evaluating Hugo is doing. Wow. Yeah, exactly. That's where I got to about 4 weeks ago. And that's the reason we asked for the challenge. So Srihari, many people are evaluating many different models. I'll tell you based on what I know right now that there are at least 4 companies that we know of, 4 big companies, actively working to build a commercial product based on this capability. And so we are sure that 3 EDA companies plus a company called Rapid Silicon are all working to try to build products based on this kind of ability. And they're evaluating every available model all the time. And so are people evaluating many models? Yes. Are we personally evaluating multiple models? Not in a systematic way, Srihari. We're looking at what we need to be able to do just enough to be very interesting in the open source space. And when we get to the point where we learn from the community what the state of the art is, we're learning literally as much as everybody else here is. I didn't know what Hammond and the NYU team had done 4 weeks ago. I got introduced to them as a result of coming up with the idea of having this competition. They shared with us what they've done from a research perspective, and they shared with the community by allowing us to post all their papers online. And so, we are learning as much as anybody else. There was a question there. Where do you get the test benches generated from AI for verifying? Where do we have the test benches for generating RTL generated from the AI chat? We don't have a suite of test benches in any specific location, and we would expect you to create obviously a repo and go do the work to create a user project and instantiate everything there.
Yeah, I can touch on that at the end here as well.
So to Luis, I can answer that one quickly. I have not tried either formal or functional verification with ChatGPT. The paper clearly covers that other people have. There are multiple examples of it online. There are even YouTube videos of people using it for code verification. So if you Google a little bit, you will discover that there has been some functional verification work done. There's been very little formal verification work done. Okay. Has anybody tried to generate transaction level verification or Verilog with GPTs yet? I have not, Philip. Don't know. Would be a great idea. It'd also be fascinating to generate analog mixed signal code. And I haven't seen anybody working on that yet, but it would be a great use of the tool. To be effective, there has to be a big enough training database of code in the open source domain for the tools to be able to learn. And part of the exercise we're going through is to get some more code out in the open source domain that the tools can use to learn. Right? The only things they're using to learn are open sourced code.
It's going to learn from its own code and go down a terrible spiral.
It could go down a horrific spiral. Yes, if we don't steer the code in the right direction and try to get design examples that work, it could be a very rapid negative spiral. much like Twitter tweeting bad things with various AIs. Yeah. Okay. Anybody got anything else? I think I'll let Jeff take over with the how to get this into a new project.
Great.
And Andy, you can, on the questions, you can click on type answer and do typed answers instead while Jeff's talking. To Tonio, I have not seen it work with an analog design yet. We have had 2 people request to try to do analog designs as part of the submission process. I don't know how they're going to do that. I didn't know whether they were going to use something like the Berkeley analog generator and drive it with an AI, or whether they had come up with a way to do AI directly to P cells. So I don't know how they're tackling that problem, but 2 people have requested analog submissions. We have said that as long as they're able to fit into the Caravel user project and they understand how to integrate, that we will accept anything that's open source and meets the rules.
I'm going to go ahead and share. Is that right? Okay.
Sure.
Do I have the right window? Let's see. Yes. Okay. So kind of picking up from where Andy left off, once you have RTL, you have your block design, you have it integrated into a user project wrapper, you will want to implement that inside of a project, a public repo project on GitHub. And the recommended way to do that is to start with this URL here, which I will, if it's not already posted, we'll make sure it's available. I think I actually posted that as an answer to a question, but you want to go to the eFabless organization under github.com. You'll find a project called Caravel User Project. And this, from this project, you can use this as a template to create your own repo. And that's typically the normal process for starting a project on GitHub or for chipIgnite. So you'll clone that project, you'll give it a name. It'll create a copy of that project with your own name under, in your own under your own user account, and then you can go and clone that locally to your own desktop, either your laptop or Linux desktop or whatever you happen to be using. Linux is definitely, if you have access to a Linux desktop, that's definitely the recommended approach. And there's documentation on specifically how to work through each of the steps of using that repo on a read the docs that's linked to that same repo that I just referred to. But in general, what I'm going to show you is inside of this project, there's 2 things I'll point you to. One is if you go into this, you'll see a Verilog directory. The Verilog directory has underneath that, there's an RTL directory for hosting or homing your Verilog for your user project wrapper. So this is where you're going to want to replace the Verilog that's here with the Verilog for your design. You should have a user project wrapper.v at the top level, right, for your design. It also in this directory, in the directory under called DV for device verification, design verification, there's another directory for your test benches. And there's some examples of test benches implemented here for the example project in this repo. I'd recommend taking a look at that. I think there's some basic documentation for how to run and use the simulation kind of setup that's in here. There's a makefile target to actually run the simulation once you have everything kind of in place. But if you take a look at one of these examples, you'll see there's a test bench here, a Verilog file for test bench. There's a .c for the firmware that runs on, that you may be running on the RISC-V core that's part of Caravel. if you're using that to drive your project, you'll want to implement your firmware there, and then the makefile builds that firmware and uses that as part of the simulation. So those are just some high-level pointers in terms of kind of how to get started in terms of integrating your design into a Caravel project that you can then submit. Right. So once you've done that, you've run verification, you've confirmed your design works as spec'd or as intended. One of the final steps is you're going to go to the eFabless platform and you're going to create a project to submit it. You'll typically I recommend logging in with a LinkedIn account if you have it, but it does also accept like Google and GitHub as well if you prefer to use that to register. And then on the main page when you're on platform.efabless.com, which is kind of what you do once you're logged in, you'll find a shuttle for the June shuttle here at the bottom called where there's a section called Active Shuttles, and there's a button in the far right corner called Start Project. That Start Project is what you use to create and implement or create your project on the platform itself so that you can submit it. So the couple of things you're going to want to do here is one is you're going to want to give it a title, right? My project. You're going to want to change the visibility to public because all the submissions for this contest need to be public repos. You need to provide some sort of a description, right? For what the project is. And then the last bit is you want to provide it a GitHub URL in the Git URL field here. So you don't have to worry about this one for the tarballs because that's for private projects. For public projects, you need to provide it a Git URL. This is the URL to the Git repo that we just talked about earlier, that you created from the template of the Caravel user project. And when you provide this URL, you have to include the .git extension, otherwise it will fail. Right. The other thing we're asking you to do is if you could put in a label. I believe the label is posted on the page, but it's like AI content, or was it AI design contest, I believe. Hopefully I have that right. But we're asking you just include a label just so we can easily identify the project as a submission for the contest. Okay.
Yeah, and it's worth saying that all of this is covered in the video that's linked in the slides. The MPW6 walkthrough, it's called.
Great.
So
else I should cover, Matt?
like 15 minutes over time now.
Okay.
Quite a few people have already logged off.
Yeah.
So I think it's about time we start wrapping this up. Was there anything, last things that either of you wanted to say?
I look forward to seeing everybody's submissions for the contest and the chipIgnite and MPW runs upcoming. And hopefully everybody has a much better bring up experience than the guys have had in the past, and they get to echo Matt's 1 to 2 hour experience as opposed to multiple day experience. So hope to see you all in the future. Yeah,
and I say if you do have questions, obviously the two go-to places for this contest are the channel, which is the generative AI channel on the Slack community. There's links for that, or you can email us at shuttle@efabless.com. Great.
Okay. Thanks everyone for joining, and see you on the next one.
All right.
Thank you very much.
Thank you guys.
Thank you for hosting, Matt.
Bye-bye.